Hi guys, today we'll be solving this problem of waves on a string. So the problem says that a transfer pulls with a speed of 200 meters per second along a copper wire of 1.5 millimeters of diameter. They're asking us for the tension in the wire and that has a density of 8.92 grams per centimeters cubed. Well, in a wave, the transfer pulse goes from an extreme to another, and in this case is of 200 meters per second. And also, they are saying to us that the wire is of copper and has the density of 8.92 grams per centimeters cubed. And they're asking us for the tension of that wire. And we know that the velocity of a wave is described by the following equation: the square root of the tension over the linear density. And this force is the tension that we are looking for. So we only have to isolate this force, but we don't have the linear density. But what we have is the density of the copper, and also we have the diameter, which will help us to find the area, because the linear density is described by the density times the area of the object. So they are already giving us the diameter, but in millimeters, so we have to convert that into meters. As well the density, because it's grams per centimeters cubed, we have to convert that into kilograms per meters cubed. Now that we already have all the values, we only have to substitute them in our equation. And our equation is the velocity squared times the density times the radius squared. So we only have to substitute those values in here. And remember that they are giving you the diameter, so you have to divide this into two, because the radius is the diameter, half of the diameter. And that will give us the force of the tension of 630.5 newtons. Hi guys, today we'll solve this problem that I write up here. So they're asking us for the force of a string when we change its velocity. That at first we had at 20 meters a second velocity at the tension and with a tension of 6 newtons, and then they are asking us for that same string to go faster with 30 meters per second. So they are already giving us the first tension of 6 newtons, and now we want the second tension of this of the same string, but at this new velocity. So we know that the equation of the velocity is the square root of the tension over the linear density. So since we have it's the same string but it's going to different velocity, we'll have two equations of the velocity, of velocity 1 with force 1 and the velocity 2 with force 2. Since it's the same material, we aren't changing the material, it will have the same linear density. So that part will help us to cancel out our equation. So we only have to isolate the linear density and we'll get the force between the velocity squared. Since it's the same linear density, we can assume that the same equation will apply to the second velocity and the second force. And we have all the values, the force 1, the velocity 1, the velocity 2, and we only have to isolate for the second force. Now we only have to substitute the values in our equation and we'll get a force of 13.5 newtons.